Alrighty, how you going? Welcome year 11 you should be if you're watching this. We are looking at the unit of locus, and locus is new. The geometric interpretation of what's going on is pretty significant. We're really connecting points and lines and algebra and graphing all kind of into one nice unit. So you should have seen the circle at this stage, and you should have talked a little bit maybe about the locus between 2 points as well. What we're concerned with today is the locus, so the equation of a point equidistant from a point and a line. So what I've got here today, I've got for you a point and a line. I'm gonna work on getting ourselves a nice locus for these two. Okay, so the point, just for the sake of naming things, getting names out of the way, the point we're concerned with is called the focus. So my blue point there, sitting just above that 5, is the focus. And the black line I have, which is currently sitting around -1, y is -1.5, is called the directrix. Okay, so I'm after a point equidistant from the two of those. And intuitively, I'm just going to pull this down here. Looking at this, the point we're after, equidistant from the two, is the point where it is right now. So it's sitting just here at 5, maybe 0.8 is the coordinate, so 5.8. And you can see here, I think you can see pretty clearly that the points are pretty equidistant, and I'll throw a circle in there as well. And looking at the circle, you can see basically the radius here, same as radius here. I think our eyes aren't really going to trick us in this case. What we can do though, so this is a nice point here, but that's just one point. We need more points. So while we've got a point that works, there's actually an infinite number of points that work. Because what I'm going to pull my coordinate up here. So what if, say for example, we're a little bit off to the side. So looking at this, I'm saying the distance from my point to my line is the same as my point to my other point. So my focus to my locus point. And, well, it works. They're both radii of this circle. So I can draw a circle such that that works. In terms of distance to the line, the shortest distance is always the perpendicular distance. So you will see it is dropped straight down there. And distance to the point, we'll look at the shortest distance there as well. I'll just put those points on, the distances there. So these two red distances are the same as each other. And I can pull my point out, pick any x coordinate I want, and you'll see that the circle gets bigger, the distances get bigger, but they're still the same distance. So they're still both radii of the same circle. Okay. So what's happening, as my point moves sideways across either direction, the distance between my point, my focus and my point is the same as the distance between my directrix and my point. So the shortest distance there, same as the distance in there. The distance between the two of them here, same as distance of each other, and that works around. And I can trace that out. If I do trace it out, I think you'll find you get yourselves a good old parabola. Okay, and that's significant. That's a real kind of identity we need to know for the course. Okay, my vertex of my parabola is pointing right here, but I'm concerned with the focus and my directrix here, and you'll see that my locus point sticks to these. What I need to do now, what I'll go and do, I'll go and just throw up a video for you guys. Throw up a video, that sounds gross. I'll go and make a video on doing this algebraically. So what does the algebra look like in doing this? So you might want to consider what might the coordinates be of this, and then we're going to go through and work on that. Just to kind of let you know where we do start algebraically, we do assume that I think we work with the focus being 1, 0, I think it is. And my directrix, I take my directrix, I'm just going to move that to be -1. -1. So that's just like the most standard version of the parabola you can get. So we do work on that. And then using shifting functions, so you know how you do functions and you shift things around, you change the x-coordinate by x minus h, change the y-coordinate y minus k. We do apply that based on this point here. So we can move this point around, then move this point around as well, and have a lot of good fun. But algebraically, we'll start with the most basic case. I'll go through that when we get there. This app's available to you. This little applet's available to you. So get on that, have a play around, and convince yourself that it's true that this distance here is the same as this distance here. And when you trace that out, you do get yourselves a nice looking parabola. Thanks for watching, and yeah, good luck with your work.